Assalamualaikum and hi everyone. My name is Arif Aiman and today I'll be presenting about my project, a mini hydro power plant. This is a renewable project that I designed at the drainage channel behind our JKE block. Throughout this presentation, I'll explain the background, location, important parameters, system component, block diagram, and finally the impact to our community and to our community. By the end, you see how even a small stream of water can be turned into a clean source of energy for education and sustainability. I'll show the poster in a second so you can understand what I'm talking about. For my first explanation, I will explain to you about my location and why I choose this location. My chosen location is the drainage channel behind the JKE block. Why here, you might ask? First, because the water flow is continuous. Even though it's not a big river, the constant flow makes it suitable for mini hydro. We got rain here quite frequently, so there's quite a lot of water that can be channeled into my mini hydro power plant. Second, the location is close to my JKE block, so it's easy for student and lecturer to access for monitoring and maintenance. Third, it's a safe control environment, meaning we can test and learn without disturbing a natural river ecosystem. And lastly, it's a smart way of using existing campus infrastructure. Instead of just letting water flow unused, we are capturing its energy. So, this location is both practical and sustainable. It combines convenience, safety, and efficiency. For my second explanation is about the parameter. When designing a mini hydro power plant, we need to study several parameters. It is a flow rate, head height, power equation, stability, and accessibility. First, about the flow rate. How much water passes per second? More water means more potential energy. The second is head height. The vertical distance the water drops, even a small increase in head can greatly increase power output. The third is power equation. Power equals 9.81 times Q times H times N, where N is efficiency. This formula helps us estimate how much electricity we can generate. The fourth is stability. If the flow suddenly stops, the system shuts down. That's why we chose a channel with reliable flow. The fifth is accessibility. It is an easy access, means faster repair and maintenance and lower the cost of maintenance. Let's imagine a simple calculation. If the flow rate is 0.05 cubic meters per second and the head is 2 meters with 60% efficiency, the power output is about 0.6 kilowatts. That's enough to light several LED lamps or even charge your laptop. This shows that even with small water flow, real energy can be generated, especially for learning purpose. So, students that need to charge their phone or laptop for anything emergency like your presentation or anything can be used here for easier access. For the third explanation that I will explain is the component. My mini hydro power plant system has several main parts. The first is the intake, the second is the penstock, the third is the turbine, the fourth is the generator, the fifth is inverter and control system, and the sixth is distribution system. I will show each part after I explain each part. So maybe you can buy and do it yourself. For the first part is the intake. This is a direct water from the channel into the system. And the second part is a penstock. A penstock is a pressurized pipe that guides water to the turbine. And this is the penstock that I bought. And the third is the turbine. Convert the energy of falling water into rotational motion. And this is the several turbine that I researched about. The fourth is the generator. A generator transforms mechanical rotation into electrical power. and this is the several generator that you can buy and that I researched. And the fifth is inverter and control system. Its main job is to stabilize voltage and frequency for safe use, and this is the part that I researched about. And the sixth is distribution system. This part deliver electricity to campus load such as light and socket. This is the distribution system that you can see. So each part is very important and plays a vital role. For example, if the intake is not filtered, leaf or debris may block the turbine. If the penstock leaks, pressure is lost. So design and maintenance are key in this system. So the fourth part is the block diagram. This is the block diagram that I'm talking about. Here's my system diagram. Water firstly enters the intake. It flows through the penstock, spins the turbine, which rotates the generator. The generated electricity passes through the inverter and control unit, and then powers lamp or socket in the JKE block. It's a simple closed loop process. Water in, electricity out, and the water continue its path without pollution or waste. I will show a simple block diagram that I made and a simple video so you can understand it more clearly. So, for my fifth explanation, I will tell you about the impact to our community, to our JKE block, and to our student and our lecturer. So, what impact does this project bring, you might ask? So, for the first is educational impact. Students can observe renewable energy in action without ever needing to go to a real and bigger hydropower plant that can be costly. It is beyond textbook and it's also a living lab. For the second is environmental impact. By using green energy, we reduce dependence on fossil fuels and support the campus eco-friendly initiative and also help the earth to be cleaner. For the third is economic impact. The water source is free. Once installed, the operating cost is very low compared to buying electricity. You only need to maintain it every month or so, and you got free electricity in your backyard. For the fourth is innovation. It serves as a model for other small-scale projects like powering rural village or remote facility. For the fifth is community benefit. This project raised awareness of renewable energy among students, staff, and visitors. It's not just about saving money, but also inspiring future engineers. So the impact is educational, environmental, economical, and social. So, in conclusion, this mini hydropower plant project shows that renewable energy can be applied even in small ways, with continuous water flow, low cost, and easy access, and also easy to maintain. It is both a clean energy source and a valuable educational tool. It highlights the importance of sustainability, innovation, and green technology for our future. That's all for my presentation. Thank you very much for listening, and I hope you now have a cleaner picture of how my mini hydropower plant system work and why they matter. Don't forget to like, share, and subscribe if you found this useful. See you next time.